Yes, good afternoon. We are going to be concentrating on finance. So for us to be able to answer the problems on finance, we have to concentrate on this formula. And this formula, 1, 2, 3, 4, 5, 6, are there on the formula sheet. And the other ones that are additional, those ones, they are not on the formula sheet, but you can be asked to calculate. But you have to take note here, the formula for depreciation here, it's supposed to be original cost minus scrap value. That one is original cost minus scrap value. And based on our variables, original cost is P, our scrap value is A. They can call it scrap value, they can call it book value, or they can use net book value. They can also use other different terms or residual value. So you have to know that depreciation amount is P minus A, whilst the interest amount is A minus P. So with that, we are now going to do some questions. So we are now having a question there. So if we are to check the question here, you are told 6.1. We are told that Patrick deposited an amount of 18,500 into an account earning R% interest per annum compounded monthly. After 6 months, his balance was that. They wanted to calculate R. So it means from our formula, we are going to use this formula. Why? Because it's compound interest. We are going to have, because it's a lump sum invested and getting that. So using that formula there, we are just going to copy the formula. So we are having our A being equated to, our A is equal to P open bracket 1 plus I to the power n. Our A is the accumulated amount. So our A will be equal to So our A will be equal to 19,319.48. Then we are having P, which is the initial investment, is 18,500. Then we have our I. Our I is going to be equal to that R. They said R%, so it means R over 100 divided by 12, because we are told it's being compounded monthly, divided by 12. This will, which reduces to R over 1,200. Then we are having our N, which is equal to 6. Substituting these values in the formula, we are left with 19,319.48 being equated to 18,500. Then we have our bracket 1 plus I, which is R over 1,200 to the power n. Our n is 6 months. So from there, it means we are now going to divide both sides by 18,500. Come here, divide by 18,500. Now that we are dividing throughout there. So by so doing, there, here we are dividing by 18,500. These divide each other. So we are now left with 19,319.48 divided by 18.5 being equated to 1 plus R divided by 1200 all over to the power 6. So to remove that exponent, we are going to get the sixth root. So it means here it's sixth root. We also get the sixth root. Then simplifying that, we are left with that as the sixth root of, if you check these ones, we will be left with the sixth root of 19,319.48 divided by 18,500. This is equal to 1 plus R over 1,200. Then we subtract the 1 both sides. If we subtract the 1 both sides, we'll end up having, it means here we'll end up having minus 1. So we end up having the sixth root of 19,318 319.48 divided by 19.5 minus 1 being equal to R over 1,200. Then from there, we have to multiply both sides by 1,200. Come here, this whole thing multiplied by 1,200. So this one and this one will divide. So our R will be equal to, means we now have to use our calculator. Our R will be equal to, punching on the calculator, so we are going to have 1,200 multiplied by the sixth root. It's not cube root. So it's the sixth root of, there is 19,319.48 divided by 18.5, not 19.5. We are having minus 1. Sorry, the minus 1 is not under root sign. So if we check that, when you convert it, it's going to give 8.70%. 8.70%. And the question was saying calculate the value of R. So here is our R. Take note here, it's 18, not 19 point. It's 18 point, not 19 point here. So This is the answer. Then we go to the next question. It's saying calculate the effective interest rate. So to get the effective interest rate, so it therefore means we are going, let's erase this part. We got our answer as 8.7. Let's take that. We got our R being equal to 8.70%. So we are going to question 6.1.2. So the effective rate will be equal to, take note this formula is not there on the formula sheet, so you have to know it. So it's gonna be 1 plus I, the nominal rate, divided by the number of compounds raised to the power those compounds minus 1. So simplifying that, the effective rate, nominal rate, we found it to be 8.7%. So it's going to be 1 plus that rate, which is 8.7. We have to take note there. It means my nominal rate there is going to be 8%. Let me write it in other words. We are saying the I nominal is gonna be 8%, which is 8.70 over 100. So if you convert that, it's going to be 0.0870. So that's the nominal rate. So that's what we are going to substitute. And our M is representing the number of compounds. We are told monthly here. So our M is 12. So substituting that, we are going to have 0.087 divided by 12 raised to the power 12 minus 1. So punching that on the calculator, we are going to have our I, the effective rate. So slightly, so we are going to bring in the calculator. So it means we are going to say 1 plus 0.087 divided by 12 there. Then it's going to be raised to the power 12 minus 1. That is what we are getting, 0. That value, but if we want it as a percentage, multiply that by 100. So leaving our answer to 2 decimal places, we see we are getting that. So we are getting 0.5 0.55434. So that answer, if we are to now write the final answer, it means to 2 decimal places, that will be 9.06%. 9.06%. This becomes, that is to 2 decimal places. This becomes our effective. So here, our effective annual rate is 9.06%. So at the end, let's answer the question. The effective interest rate is equal to 9.06%. Then we go to the next question. They said Kuda bought a laptop for 10,000 on 31 January 2019. He will replace it with a new one in 5 years' time on 31 January 2024. The value of the old laptop depreciates annually at the rate of 20% per annum according to the straight line method. After how many years will the laptop have a value of 0? So let's go to the next one. So we are going to, yeah. So they said we are using the straight line method, and the formula for the straight line method, here it is. So using the straight line method, we know how do we calculate our depreciation. It means it's going, so it's question 6.2.1. 6.2.1, we know our A is equal to P open bracket 1 minus IN. But what's our A? Our A is the residual value they told you to 0. So our A here is 0. Then our P is the initial cost of the laptop, which they said is 10,000. Then we have our I, which is the depreciation rate, which we are told 20%. If you divide that by 100, it becomes 0.2. Then our N is what the question requires you to calculate, which is the number of years for which the laptop. So using that, it means we can say A is 0 equal to 18,000. Sorry, 10,000, not 18. Then 1 plus I, which is 0.2, and like that. From there, divide both sides by 10,000. Here, divide by 10,000. Here, divide by 10,000. So here, they are going to divide each other. So from there, it means you'll be left with n. 0 divided by any number is 0. So we are left with 0 being equal to 1 plus. Sorry, it's not plus, it's minus here. It's minus, not plus. From the formula, it's minus 1 minus 0.2n. Transposing that to that side, it means 0.2n is equal to 1. Dividing both sides by 0.2, here divide by 0.2, here divide by 0.2. It therefore means that the n will be equal to, what's happening with it? Simplifying that, you get our n being equal to 5. So here, our n will be equal to 5 years. Alternatively, when you are dealing with reducing balance method, and you are told the residual value will decrease to a value of 0, you can just divide the total price, which is 100%, by the rate of depreciation. Meaning to say, alternatively, it was possible to just say our N is equal to 100% divided by 20% if you are told the time it takes for the product to arrive at 0. So we would realize that in that case, our N again is 5 years. At the end, let's not forget to answer the question. The question is asking how many years will the laptop have a value of 0. So it means we answer the laptop will have a value of 0 rand after 5 years. Then we are told Kuda will buy a laptop that costs 20,000 in order to recover the cost price. In order to cover the cost price, he made his first monthly deposit into a savings account on 28 February 2019. He will make his 60th monthly deposit on 31 January 2024. The savings account pays interest at 0.7 per annum compounded monthly. Calculate Kuda's monthly deposit into this account. So if we are to check from what we are given there, the cost you are given, the cost that is when he wants to buy the laptop, meaning to say this is the future value. But to cover for this future value, he wants to be paying from now. So it means he wants to be paying monthly payments, 60 monthly payments or monthly deposits into a savings account. So it means we have an annuity. So we are going to use the formula for future value of an annuity. So it's more the same way we deal with a sinking fund. So let's create here for the next question. So here we said 5 years. Now, this one we are going to use, that's question 6.2.2. We are going to use the formula for future value of an annuity, and that formula is there on the formula sheet. So you have to go and pick it. Here is the formula that we are going to be utilizing. This one we already used it. Here's the formula that we are going to be utilizing. So make sure you copy the formula correctly. So it's saying X. Then we put a bigger bracket. It's gonna a smaller. Then it's 1 plus I to the power N minus 1 all over I. Then identify the variables. We have F. That's the future value of your annuity. You are told that the laptop will cost 20,000. So this becomes your F. Then X there, it represents the monthly deposit into your savings account. But this one, we don't know it. Then we are having our I there. If you check our I, we are told it's 8.7 per annum. So it means it's 8.7 divided by. So that rate, if you convert it to a decimal, it's going to be 0.087. Then divide that by 12 because you are told that it's being compounded monthly. You are told that it's being compounded monthly. Then you also have to take note that our N is equal to 60 because we are told that there are 60 monthly deposit. So using that, we can now substitute this variable. So it means 20,000 will be equal to X, which we do not know is the monthly deposit there. Then bigger bracket, we are going to have 1 plus our I is going to be 0.087 divided by 12. The minus 1, we close bracket, all over our I, which is going to be 0. Sorry, we are having to the power n there, n which we said is 60. So it means we are now going to have here 0.087 all over 12. Then from there, we want to solve. So it means here we multiply both the numerator and the denominator. So it means we are going to have multiply here. So it means here it's going to be 0.087 over 12 there. Then here we are going to have this, which is 1 plus 0.087 over 12 to the power 60 minus 1. What we do on the right-hand side, we do it on the left-hand side, meaning to say here again, we have to multiply by 0.087 over 12 divided by that which is 1 plus 0.087 over 12 there to the power 60 minus 1. If you check on our right hand side, this one will divide by this one, and this big bracket will divide by this one. So we are left with X. So eventually our X will be equal to, we go to our calculator and punch that value on our calculator. So here we go. Here. So that value, simplifying, we are going to have fraction. So it's 0.087 divided by 12 times 20,000 all over. We have our bracket. So it's 1 plus 0.087 over 12. That is going to be raised to the power 60 minus 1 as our denominator. Simplify that. This is the answer that we are getting, but because we are dealing with money, it means our answer must be to 2 decimal places. So it's going to be 267.26. So our X is equal to 267.26. This is the value of our X. Let's answer the question. Kudas monthly deposit. So we are going to give that, therefore, Kudas monthly deposit, therefore, Kudas monthly deposit equal to 267.26. Then we go on to the next question. So the next question is saying, Tino wins a jackpot of 1,000, 1 million, 1.6 million. He invests all his winnings in a fund that earns interest 11.2% per annum, compounded monthly. He withdrew 20,000 from the fund. The end of each month, his first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 would Tino be able to take from this fund? So it means what we are having, you are told that we know Tino wins and invest that money. So it means this is the money that he wins now and invest it now. So it means this is the present value, this value. But he's going to be withdrawing 20,000, meaning to say monthly, meaning to say they are periodic withdrawals, meaning to say it's an annuity. So you use the formula for present value of an annuity. So copy that formula correctly from the formula sheet. So P is equal to what? Make sure you got your formula sheet straight. Don't memorize these formulas. Here is the formula. We choose an annuity because they are periodic payments. The moment we have periodic payments, we use this. We are just have to understand, is it future value that you want or you are given or present value? So we are going to use this formula. So how are we going to apply the formula? Here it is. So using the formula, our P is equal to X, bigger bracket, then we have 1 minus, open bracket, 1 plus I to the power a negative n, close bracket, O over I. Then you have to identify what is it that you are given. You are given P, which is the amount, the lump sum which he wants to invest now, which is 1.6 million. Then X is the monthly withdrawals, which we are told that they will be 20,000. Then I there, you are told it's 11.2%. Converting it to a decimal, it's going to be 0.112 because you divide that by 100. Divide by, because you are told it's going to be compounded monthly, so you divide that by 12. Then your N is what they want you to calculate, how many withdrawals will be made. So if we are to check, this is what we have. So simplifying, we are going to have, let's substitute. So it means we are going to have 1.6 million being equated to X, which is 20,000. Then it's 1 minus then bracket 1 plus our I is 0.112 over 12 to the power a negative 60. Sorry, we do not know n. We do not know over a negative n or over I, which is 0.0 0.112 divided by 12. Then from there we are solving. So it means we are going to multiply both sides here. We multiply by that denominator 0.112 over 12. Then we divide both sides by that monthly, which is 20,000. We are also going to do that to the left. So here it means we are also going to multiply by 0.112 divided by 12 over 20,000. So simplifying that, it means this is going to divide with that. This is going to divide with that. So it therefore means you'll be left with this part, which is 0.112 over 12 multiplied by, if we simplify here, dividing, you would realize that 1, 2, 3, 4 zeros, 1, 2, 3, 4, 4 zeros. So it's multiplied by 80. Yeah, it's going to be multiplied by 80. But this must be equal to 1 minus, it's 1 plus 0.112 over 12 to the power a negative n. This negative we now want to solve, so it means we are going to transpose this one, that bracket. Then when you take it there, it becomes positive. Then we take this part to this side. If we do that, it means we are going to be left with, so here. So when we take that to that side, we are going to be, it becomes positive. It will be 1 plus 0.112 divided by 12 to the power a negative n. This must be equal to 1 minus 0.112 over 12 multiplied by 80. This is what we are having. So to simplify that, it means our negative n will be equal to, here we are applying the logarithms. Using the logarithms there, we know that if we are told that a to the power n is equal to b, it therefore means n will be equal to log b base a. So in this case, our power, we leave it, this is our power. Then we are going to say log with this base. So log, our base is going to be like that. So it means here it's going to be negative n equal to log. So our base is going to be 1 plus 0.112 over 12. Then here we are going to have that which is 1 minus 0.112 over 12 multiplied by 80. Then with that, we just go on our calculator. So our negative n will be equal to it's going to be, it means we have to introduce the calculator. There it is. So we are going to have a log here. Then our base is gonna be 1 plus 0.112 divided by 12. Then there we are going to have 1 minus 0.112 over 12 multiplied by 80. So we are getting 147.7, which is negative. So we are getting 149 point. We are getting as our answer negative 147.7978 as shown on the calculator. This is what we are getting. So it means by negating, our earning will be that positive. But let's go to the question. It's saying how many withdrawals of 20,000 would Tino make? So in this case, we are seeing that we have got 147 withdrawals of 20,000. The last withdrawal is less than 20,000. So in total, we are having 148 withdrawals. But if you check the last withdrawal, because it's represented by the fraction part, it's less than 20,000. So the question wants withdrawals of 20,000. So the withdrawal of 20,000, they are 147. So it means we are going to put that as there are 147 withdrawals of 20,000. That becomes our answer. So we are saying there are 147 withdrawals of 20,000. So you have to take note there on how the question has been asked. How many withdrawals of 20,000? That's why you used the 147. But if the question had just asked how many withdrawals, they were going to be 148, and the 148 one was going to be less than 20,000. Right. Then kindly take note that I always wish the best from you, my learners. Always when to master this, just make sure that you're building strong foundations. It is very essential for you to understand essential concepts and definition, and these are vital for tackling advanced mathematical topics. As you can see in this case, the finance part was at the beginning. You needed to know the basics of algebra, how to solve linear equations, how to solve exponential equations, which are the basics. So for you to master that, it means you needed those basic concepts of algebra. You have to practice problems regularly. You have to do different problems so that you get used to how the questions are being asked. Then lastly, you have to reflect and relate. You have to review mistakes. You have to seek help if needed. You have to connect mathematical ideas to real life situations for deeper understanding, not just working for the sake of answering or for the sake of getting the correct answer, but learn to relate what you have learned to the real world, because what we are doing here is related to what really happens in the world of finance. Thank you very much. I always wish you the best.